In the previous lecture, we have discussed the introduction about rivet joints. So, in this lecture, first we'll see the design procedure of rivet joints, then we'll move into the problems on rivet joints. So, in rivet joint design, you can split the type of rivet joint into two, as we discussed earlier in the previous lecture. One is lap joint, and the another one is butt joint. So, in case of lap joint, we don't need to use any cover plate, but in case of butt joint, we have to use some cover plates to hold the two plates together. Okay. So, the first point of the design is thickness of the cover plate, and this first point is applicable only for the butt joint. So, in case of lap joint, this first point can be neglected. Okay. So, in case of butt joint, the thickness of the cover plate. So, here you can see that for a single cover, the T1, that is thickness of the cover plate, is equal to 1.125 times of the thickness of the plate. So the in most of the problems, the thickness of the plate will be directly given in the problem. You can take the value and you can calculate the thickness of the cover plate from the thickness of the plate. Okay, so these relations are in data book page number 7.127. Okay, so all the equations used in design of rivet joints are used here in data book page number 7.127. So you can refer that. So in that, for single cover, you can see that it is T1 is equal to 1.125 times of T. Then for a double cover of unequal width joint, then T1 is equal to 0.625 T. Okay. So if these two are for equal width joint, and in case of unequal width, the T1, that is thickness of the inside plate, is 0.7 times the thickness of the plate, and the T2, that is thickness of the outer cover plate, is 0.625 times of the thickness of the plate. Okay, so this is for uniform width problem and this is for unequal width problem. For example, if the thickness is not directly given in the problem, then you can calculate the thickness by using this equation, because in some of the pressure vessel problems, they will give the pressure and diameter of the pressure vessel. So we have to calculate the thickness by using the pressure and the diameter. So this equation is also available in data book page number 7.126, and the equation is T is equal to P into D divided by 2 nu 1 sigma T. Okay. So here T is the thickness of the plate. Okay, so there is a difference between plate and cover plate. For example, if you are having two plates like this, then this is T, the thickness of the plate. And in case of butt joint, we will use a cover plate or two cover plates. Then this is the thickness of the cover plate, T1. Okay. So if T is directly given in the problem, then you can directly calculate T1. If T is not directly given, then you have to use this equation to find the value of T. So the equation is P into D. Here P is pressure, D is the diameter of the pressure vessel, nu 1 is the efficiency for longitudinal joint. Okay, so this efficiency you can take from PhD data book 7.126, and sigma T is the allowable tensile stress of the rivet material. Okay, so sigma T will be given in the problem. You can use it and you can find the value of T. So after finding the value of T, you can use these empirical relations to find the value of T1. Okay, so this is first point, and this point is applicable only for the butt joint, not for lap joint. So if it is lap joint, then you can directly start from point number 2, that is diameter of the rivet. Okay, so we have two criteria for selecting the diameter of the rivet. The first one is if the thickness of the cover plate is less than 8 mm, then we have to equate the Fs, that is shear force, into the crushing force. So if the thickness of the plate is less than 8 mm, then you can equate Fs is equal to Fc. And we know the equation for shear force, that is I into N pi d square by 4 into tau. So this equation is there in the data book page number 7.124. Okay, so you can refer that. So here I is the number of rivets and N is the number of cross sections under shear. For example, if it is lap joint, then this is your rivet. So if this is your rivet, then this region is alone subjected to shear stress. So in case of lap joint, the number of cross sections under shear is 1. For example, if you have a butt joint and you have two cover plates, remember, assume that you have two cover plates. So this is your single rivet. So here you can see that, so 1 and 2, there are possibility for two regions under shear. Okay, so in case of double cover, then the number of sections is 2. So it is based on the given problem. And I is number of rivet. It will be given in the problem. Then here D is the diameter of the rivet, and tau is the shear stress of the rivet material. It will be directly given in the problem. Then Fc is equal to I d into T into sigma c. So I is number of bolt, D is the diameter of the rivet that you want to calculate, and T is the thickness of the plate, sigma c is crushing strength of the rivet material. It will be directly given. Okay, so once if you substitute the values except D, then you can equate these two equations and you can calculate the value of the diameter. Okay, so this is for the thickness less than 8 mm, but it is very rare because most of the plates will have a thickness of greater than 8. If the thickness is greater than 8, then the procedure is very simple. D is equal to 6 into root T. Okay, so the equation is there in data book page number 7.126. You can refer that. Okay, so D is equal to 6 root of T. Here T is the thickness of the plate. Okay, so this is the second step. The third step is margin of the rivet. So we know what is margin. Okay, so it is the distance between the plate end and the first rivet. Okay, so that is E. So the margin of the rivet E is equal to 1.5 times the diameter of the rivet. Then the fourth step is pitch of the rivet. Okay, so to calculate the pitch of the rivet, we have to equate the Fs into Ft, because if you have two rivets like this, then Fs is the shear force acting on this rivet joint, and Ft is the tensile force acting in between these two joints. Okay, so the material should not fail by Ft as well as the Fs. So we have to select the P for Fs is equal to Ft. So for a safe value of Fs and Ft, what should be the pitch value that we have to calculate? Okay, so the equation for Fs is same as we discussed earlier. It is I n pi d square by 4 into tau. So now you know the value of D because we have already calculated the diameter of the rivet. So anyway, this equation is there in data book page number 7.124. You can refer that. And the second equation is Ft equation, that is tensile force in between the rivets. Okay, so the equation is so this equation we have already derived earlier. Anyway, this equation is in the data book, you can refer that. So Ft is equal to P minus D into T into sigma T. Okay, so here P is the pitch, D is the diameter of the bolt. So actually P we have to calculate. Then T is the thickness of the plate, and sigma T is the tensile stress acting on the plate. Okay, so sigma T will be directly given. So by equating this Fs and Ft, you can calculate the P value, because except the P value, we know all the remaining values. Okay, fine. So you can calculate the pitch value. So once after calculating the pitch value, we have to ensure whether the calculated pitch is under the safe limit. So the maximum pitch is Pmax is equal to Ct plus 41. Okay, so substitute C is a constant. Okay, so C we have to take it from data book page number 7.126. I'll show you how to select the values from data book. Then this T is the thickness of the plate plus 41. Okay, so we have to calculate the P maximum value, and your calculated pitch value should be less than the P maximum value. Okay, so if it is not less than the P maximum value, then you have to use the P maximum value as pitch value. So whichever is minimum, you can select it. Okay, so if the P value is less than P max, then you can directly use the P value. If the p value is greater than p max, then you can use the p max value as p value. Okay, so this is the maximum limit for pitch value. It is based on the Indian boiler standards. Okay, IBR. So this is the fourth point, that is calculation of pitch. Then after calculating the pitch, the fifth point is distance between two rows of pitches. I mean two rows of rivet. So we have two rows of rivets on a plate. So this is chain structure. So in case of chain rivet, then PB, it is the distance between two rows. In case of chain rivet, PB is equal to 2D. In sometimes we may have zigzag type of rivets. Okay, so in case of zigzag rivet, then PB is equal to 0.33 times of pitch plus 0.67 times of the diameter of the rivet. Okay, so here P is the pitch and D is the diameter of the rivet. Okay, so in the problem they will specify whether it is chain rivet or zigzag rivet. You can select accordingly. Then the last point is efficiency of the joint. Okay, so nu is equal to the least value of Fs, Ft and Fc. We have to take the minimum value among Fs, Ft and Fc, because Fs, Ft and Fc values we have already calculated earlier. Okay, so you can compare the values and you can take the minimum value divided by P into T into sigma T. So here P is the pitch and T is the thickness of the rivet and sigma T is the tensile stress. Okay, so you can calculate the efficiency of the joint. Okay, so this is the design procedure for riveted joints. So for butt joint, you have to start from the first point, and for lap joint you can directly start from the second point. Okay, so now I'll tell you how to take the values from data book with the problem. So the first problem is two plates of 9 mm thick are to be joined by a triple riveted zigzag lap joint. Okay, so triple riveted means the number of rivets is 3. So I is equal to 3. Then since the plate thickness is 9 mm, here the plate thickness is directly given, so we can directly take the plate thickness value. T is equal to 9 mm and the type of riveting is zigzag. Okay, so T is 9 mm, I is equal to 3 and it is zigzag riveting. Design the joint using the allowable stresses as 80 megapascal for plates in tension. So sigma T is 80 megapascal, 60 megapascal for rivets in shear. So tau is 60 megapascal and 100 megapascal for rivets in crushing. So sigma C is 100 megapascal. Find also the efficiency of the joint. Fine. So this is the given drawing. So from the drawing you can identify that it's a lap joint. 3 rivets are used. Okay, 1, 2 and 3. And the T is directly given. So as I told you earlier, for lap joint, you don't need to calculate the thickness of the cover plate because for lap joint there will be no cover plate. So you can directly start from the point number 2, that is the diameter of the rivet. So I have considered the point number 2 as 1. So the first point is diameter of the rivet. And for calculating the diameter, as we discussed, we have two conditions. One is for T less than 8 mm and the another one is T greater than 8 mm. Okay, so here the T value is greater than 8 mm. So we can use the equation directly, that is D is equal to 6 root T. Okay, so it is 6 root T is root 9, that is equal to 18 mm. This is the diameter of the rivet. Then the second point is margin of the rivet. So E is equal to 1.5 times the diameter, that is 27 mm. The next point is pitch of the rivet. And we know that for calculating the pitch of the rivet, we have to equate the Fs with the Ft. So Fs is equal to I into N into pi d square by 4 into tau. So don't directly write the equations. Use the data book and take the equations from the data book. Okay, don't try to memorize all the equations. So here I is the number of rivet, N is the number of cross sections under shear, then D we have to calculate and tau is given. So I is 3, N is 1, because since it is lap joint, so for one rivet, there is only one region is subjected to shear. Okay, so this N is only for one rivet. Okay, so it is 1, then pi into 18, that is diameter of the rivet, divided by 4 into 60, that is 45,804.4 Newton. Then Ft is equal to P minus D T into sigma T. So here P is the pitch and D is the diameter of the bolt, it is 18 mm. Then T is the thickness of the plate, it is 9 mm. And sigma T, it is given as 8 mm in the problem. So here P is the unknown value, so you will get 720 into P minus 18. Now to calculate the value of the pivot, we have to equate these two values. So that is 45,804.4 is equal to 720 P minus 18. So if you solve this equation, finally you will get the P value is equal to 81.6 mm. So now we have to calculate the P maximum value. So P max is equal to CT plus 41. So this equation in data book page number 7.126. So P max is equal to C. So C we have to take from this graph. So this graph is there in the data book 7.126. So this is for lap joint and this is for single cover butt joint and this is for double cover butt joint. And this is number of rivets. So here in our problem we have 3 rivets and the joint is a lap joint. So for 3 rivets and a lap joint, the C value is 3.47. Okay, so I have substituted the C value as 3.47. Then the T is the thickness of the plate, it is given as 9 mm plus 41. So the P max value is 72.23 mm. So previously I have calculated the P value as 81.6 mm. So it is less than the P maximum value. So I have selected the P max value as the pitch. So P is equal to 72.33 mm. So the maximum value, minimum value you have to select it. So now we have calculated the pitch. The next step is distance between two rows. And as I discussed earlier in the design procedure, we have two equations for calculating the distance between two rows. That is one for chain rivet and another one for zigzag rivet. So here in the problem, it is clearly mentioned that it is a zigzag rivet. So we can use the second equation, that is PB is equal to 0.33 P plus 0.67 D. So here P is the pitch value that I have substituted. So remember that you have to use the minimum pitch value. Then 0.67 D, D is the diameter of the bolt. So the distance between two rows is 36 mm. So the last step is calculation of efficiency. So nu is equal to least of Fs, Ft and Fc divided by Pt and sigma t. So Fs I have calculated, Ft I have calculated, in that I have Ft is equal to 720 P minus 18. So this equation actually I have used for calculating the pitch value. Now I have calculated the pitch value, so you can substitute the value of pitch here. It is 72.33 and you can find the value of the Ft. So that is 39,117.6 Newton. Then Fc we haven't calculated, so to calculate the efficiency we have to calculate the Fc value now. Fc is equal to I dt into sigma 3. So all these equations are there in data book page number 7.124, 125 and 126. Okay, so you can refer the 3 pages, you will find all the equations. So here I is the number of rivets, it is 3. Then D. So D is the diameter of the rivet, we have calculated it as 18. Then T is the thickness of the plate, it is 9 mm, and sigma C is the compressive stress, it is given in the problem, it is 100 mm. So by solving this, I can calculate the Fc value as 48,600 Newton. So among these 3, that is Fs, Ft and Fc, the Ft value is minimum. So I have selected the FT value for calculating the efficiency. So the FT value is 39,117.6 Newton divided by P is the pitch value, that is 72.23. T is the thickness of the plate, it is 9 mm. Then 80 is the sigma T value, it is given in the problem. So the calculated efficiency value is, actually I will get 0.75. So I can multiply 100 since it is efficiency. So the calculated efficiency value is 75.21 percentage. Okay. So in the problem it is clearly mentioned that it is a lap joint and the number of rivets is given as 3. So since it is lap joint, we don't need to calculate the cover plate length. We can start from step 2. And in step 2, we have two equations. One is for T less than 8 mm and the another one is for T greater than 8 mm. In our problem, the T is greater than 8 mm, so I have used the second equation. The next one is margin of the rivet. Use this relation to find the margin. Then to calculate the pitch of the rivet, equate Fs is equal to Ft and calculate the pitch of the rivet. So after calculating pitch, check whether it comes under the maximum pitch. So use this equation to calculate the maximum pitch. Since the value of maximum pitch is minimum, I have considered the maximum pitch as pitch value. Okay. Then after calculating pitch, the next step is distance between two rows. So here we have two equations, one for chain riveting and another one for zigzag riveting. Since it is zigzag riveting, I have used the second equation. So the last step is efficiency. Calculate Fs, Ft and Fc, and among these three, select the minimum value and calculate the efficiency. So the tutorial problem is, a double riveted lap joint is to be made between 6 mm plate. So here the plate thickness is given as 6 mm. So here it is less than 8 mm. So we have to equate the Fs value with Ft to find the thickness of the plate. Diameter of the rivet, because we know that from design procedure, so for T is less than 8 mm, we have to equate Fs to Fc. It is not Ft, it is Fs to Ft to find the value of the diameter of the rivet. Okay, so for T is greater than 8 only, you can directly use this. Here the T is less than 8 mm, so you have to calculate Fs value and Fc value, and you can substitute it here to find the diameter. Okay, fine. Then it is double riveted lap joint, which means the number of rivets is 2. The safe forking stress for plates and rivet materials are sigma T is given, tau is given, and sigma C is given. Okay, sigma T, tau, and sigma C is given. The procedure is same. You can start from the second point, but remember that here the thickness is less than 8 mm, so you have to equate Fs to Fc to find the value of pitch diameter. Don't use D is equal to 6 into root T. So don't use this equation. So use Fc is equal to Fs is equal to Fc. Then for calculating the distance between two rows, actually we have two equations. One is for chain set and the another one is for zigzag. So here in the problem they haven't specified anything about that. So you can consider any one of the type of rivet. You can consider either the chain type of riveting, or otherwise you can consider zigzag type of riveting, and you can calculate the distance between two rows, and finally you can calculate the efficiency. So this is how we have to solve the problems on lap joint. Okay, so remember that for lap joint we don't need to calculate the cover plate length. We can directly start from step number 2. So just remember this design procedure. Refer the data book page number 7.124, 125 and 126 for the equations. All these equations are available in the data book. Don't memorize this. Just remember the procedure. Use the equation from data book. So the design of rivet joints will be very simple for you.